Here's a story that you've heard from Hollywood, but you've never heard from a programmer before. You've got an aging prize fighter, an old, washed-up boxer. Everyone assumes his best days are behind him. And he enters the ring with a scrappy young upstart and loses. Loses several rounds quite badly. But then goes into training and comes back stronger than ever. Sylvester Stallone stars as the Java virtual machine. I can't see Netflix picking that story up anytime soon, but I think that is the story. If you look back 10, 15 years, Java had stagnated. It was losing a lot of ground to Scala in particular, but other languages too. And it looked like while the JVM wasn't going anywhere, anything new would have to come from elsewhere. And then, against all odds, and certainly against any of my expectations, Java the language and Java the virtual machine underneath seemed to find a new lease of life. They started to pick up some momentum. Java and the JVM recently have been changing with a speed I would absolutely not expect from a 30-year-old language. And I've tried to keep up, I've tried to follow the news from afar, I've heard the buzz, but I haven't really followed the details. So when it came up, I took the chance to speak to a man who must be the most enthusiastic proponent of the JVM that I've ever met, Josh Long. And I asked him, what is all this new stuff? What have I been sleeping on? And his answer includes new techniques for high-performance computing, for data-oriented programming, for asynchronous programming without async await keywords, for a new threading model, and for a serious move for Java to get in the ring with Python and C and compete for the AI crown. There is a lot of new stuff to dive into. Before we do that, I will tell you that this episode was recorded live at the Code Remix conference in Miami. So thank you to Modern and Open Rewrite for hosting this title fight, this comeback special. Let's find out. I'm your host, Chris Jenkins. This is Developer Voices, and today's voice is Josh Long. I'm joined today by Josh Long. Josh, you've got your own reputation, but your reputation to me is, I think you're the most enthusiastic Java person I've met since Java was launched.
Cheers.
You genuinely love it, don't you?
I love the JVM. I love the community. I love the technology atop the JVM. Java, the language, it's growing on me. It's only been 30 years, I think. Another 30 years and I think I'll be there. But yeah, it's a good language. It's just not the greatest. But that's okay. I think one of the greatest is actually within the JVM community itself. So again, you celebrate that and you're still in a winning place, you know?
Which are you going to pick? Kotlin?
I think Kotlin it scratches... No, there's no perfect language.
No.
We agree on that, right? Surely.
Yeah, I can agree on that.
For 80% of all the itches I've got, that scratches them correctly. You know?
Okay. Maybe I'm going to ask you about that then. What is it about Kotlin?
First and foremost, it's an elegant modern language on top of the JVM. That's the crown jewel here, right? I stress the JVM because it doesn't matter if you like Java, nice though it is and fast improving though it is. Kotlin, the JVM is the crown jewel. That runtime, the garbage collector, the performance, the fact that even 10 years ago, before all this incredible stuff they've added, it was already one of the most energy efficient, scalable languages out there. You know, competing with the likes of Go and other things like that in a lot of areas. The fact that was true so long ago and it's just getting better. Yeah, the JVM is an amazing thing. But then, Kotlin was done with a fresh coat of paint. It was done from whole cloth 15 years ago, so it was able to sort of look 15 by now. I don't know, maybe even longer. It's 2010, 28, 2009, something like that. So I will say that I think the language designers behind Kotlin have done a remarkable job, and it shows a talent, But let's just also agree that if you start something in 2010, you're going to avoid a lot of the mistakes that befell languages started in 1995. That's just facts, right?
Yeah, I would hope that's the case. I hope we're learning things as we go along.
So even if you take nothing else from it than that, it's a fresh approach to a new language built from whole cloth in 2010, then it's already ahead. It has to be. From day zero. So there's a lot of idiosyncrasies that Java has that reflect its endearing and enduring commitment to backwards compatibility that in their approach to adding new features to the language, they sought to preserve backwards compatibility. And so there's all these little things that were retroactively grafted into the language, and they couldn't do whole cloth sort of essential refactorings of the way things worked because that would sabotage the compatibility that they so sought to preserve. So they did these things that were like half measures. And it works fine 90% of the time. It works fine. Generics not being reified works enough, and auto boxing kind of works okay. And Java not having proper, functional style operators for collections. They kind of fixed it with streams, while also preserving existing code, and just all this stuff. Records are kind of there, but then that syntax, that compact style is not there for all the classes, and just all these little like warts.
Yeah, things that if you were doing it from clean room, you wouldn't do it that way.
You'd avoid, and
but in fairness, I mean, like, I remember, I think the last time I was working in Java was probably 2012, with a couple of exceptions. And the language had basically stagnated.
Oh, for sure.
And it's amazing how they pulled out of that stagnation mine and how much they've done since then, right?
I mean, to their credit, to their enduring credit, I think Java 8 was 2014 was, I think, one of the most important years for the Java community, because that was the year both Spring Boot 1.0 came out and Java 8 came out. These two things just changed things for the better, I think. Java 8 gave us functional program, ish. We don't have tail recursion. We don't have like actual proper. There's no monad in Java suddenly, but
lament personally, but
yeah, but for the 80% where people just want functional operators on their collections and all that, it's there. You get lambdas, but again, that's another one. Lambdas, structural types as a first-class citizen, where functions are a first-class high top-level thing. That doesn't exist, right? At the end of the day, they get Java as a nominal language. Everything has to have an identity, and so everything gets reified or reconciled against an interface, which is fine, But also, I really just want to be able to have a variable whose type is a function of int and string. That returns a boolean. I want that to be enough. I don't want to have to extract out an interface where there's an apply method that takes an int and a string or whatever. And
this is the thing. Java, I still feel, has that ceremony that you don't get quite with any other language.
Well, no, but again, if you're trying to do two arguments, there's a by consumer, right? There are ways to do it that work. And for most people who ever write a Lambda using two parameters and returning a single value, you'll be fine. Heck, I think it goes up to like 3. There's even a third one. But what if you want to do 1,000?
Yeah.
Not that you would, but what if you did? In theory, Java just doesn't have that cleanliness of implementation, and so for the practical everyday use cases, Java will feel just as refreshingly clean and concise as any other language, but you find these little invisible walls. You think, well, if I can have a collection of string, then surely I can at runtime extract out rather what is the generic bound of this type. It's a collection of what? Well, at runtime that doesn't exist. It's erased, right? So there's no collection of strings, just collection. Oh, okay, so it's only a compiler thing. Oh, okay, well, still feels like it's working for me, but also I would love to be able to do that.
Yeah, it's interesting how it's a mixture of syntax and implementation details in ways holding it back, and some cultural stuff. I think like the Java. You can tell me I'm wrong, and please tell me I'm wrong. But
I don't know yet.
But Java as a world, it feels like they've boiled the frog up to the point where ceremony is normal.
No, they've gotten rid of a lot of the ceremony.
Really?
The language, again, for the 80% case, I can do. Let me try again. Hello world in Java is a class, a void main method, public static void main method, and system out print line. So there's ceremony there. Agreed. That'll go away in Java 25. You can have just void main parentheses system out print line, right?
Okay,
and no class, no nothing. So that's upfront ceremony, and I agree. If you take that versus Python just print hello world, then of course we're going to lose. But that isn't where people use either of those languages, right? Python is not a toy. You're not there to write hello world, and ditto for Java, right? Java, its strength is in the large.
The beginner's experience is important, but it's dwarfed by the expert experience.
No, it's dwarfed by the day 0.5.
Okay.
It's not your first, literally your first line of code, but you're like, I want to do anything at all non-trivial, right? And so you'll learn the ceremony and hopefully move past that. And hopefully in literally 4 months, whatever, that won't even be required. You can just say void main parenthesis, parenthesis, curly bracket, curly bracket. It's still some ceremony. Like in Python, you're taught to do if underscore underscore name equals underscore underscore and print hello world, right? So there's that, but and they're working on it. I guess is my point. They're appreciative of the fact that it's not great. They're fixing it, and that's all we can ask. A little more expediency would have been nice. But
I think it's impressive how fast Java has been moving.
Yeah.
Given the weight and the history and the amount of backwards compatibility they've had to deal with.
Yeah, and so I think for a lot of people that are used to, I rage against the public keyword. They're just so used to copying, cargo culting these. Like if every class is public, then that's an extra token that you have to add, right? I know this is a small thing, but again, you think that you have to do that, and you just don't. So how do you describe a class in TypeScript? You say class, cat, curly bracket, curly bracket. How do you do it in Java? Same thing, right? How do you describe a method that returns a string? You say string, foo, parenthesis, parenthesis, curly bracket, curly bracket. How do you do it in TypeScript? Put the colon string as the return value. It's actually longer in TypeScript. There's a colon there, right?
Okay.
It's the same exact tokens, just rearranged. So when people say it's ceremonial, I just don't, I don't get it. We don't have inbuilt, like, for example, the array type is different from the collection type.
Yeah.
Right. And so in a lot of languages, there's no such distinction. The result is that if you use an array, which is a contiguous block of memory in Java, it's super, super efficient. Right. You can do a lot of things very efficiently because we're storing primitive types. Right. And so people look at that and go, okay, well, yeah, that's ceremonious, because in Python or TypeScript or whatever, I just have bracket, and then some values in there in a literal, right?
Yeah.
And I can see where that's different, but there's a huge distinction there. Our arrays compared to other languages' lists are a billion times faster, and they're just through the roof, right?
Yeah, it's not ceremony; it's being specific.
Yeah, and I agree that for the people who are just trying to store 1, 2, 3 in a collection or a thing that aggregates them into one variable, that may seem ceremonial. And then of course we get into okay, let's say I want to support. Let's say I want to have a list of 1, 2, 3. What should that do, right? At the moment, that does the thing nobody thinks it does, which is it creates objects out of each number.
Does it?
Yeah. So you get a list of integer, not int, the primitive values.
Right.
And those are, and so that's one of those examples of where the striving to graft things retroactively onto this language it's a half measure, and it hasn't really been a huge issue, but for all performant code in Java, one just drops down to int arrays, right?
Yeah.
So in Java, you can have an array of int, you can have an array of float, you can have an array of boolean, but if you have a collection, they can only be objects. So you have to box the primitive types into these objects. You have to wrap them in these object wrappers, which means that every number now has a object header, right?
Yeah.
Well, no wonder people don't do high-performance video games in collection. They use ints, they use floats, they use arrays of things, And so that, wouldn't it be nice if those things were unified?
Yes.
And so one of the things we're working on right now is Project Valhalla, right? Which means that basically you'll have the ability to have values as first-class citizens. Like, how do you add a new primitive type in Java, right?
Do you?
Can't.
You don't. No.
There's whatever the 6 or 7 standard.
Yeah.
Boolean and float in.
And everything else is an object.
Yeah. Well, why can't I add a point, a value type called point, which is stored on the stack as just a float, but behind the scenes I can pass it around in terms of my point, an object that has an accessor for X and an accessor for Y.
Yeah.
Why can't I do that? So the Project Valhalla will unify that so that when you can write code in terms of that point, but behind the scenes you're just having tightly packed float values.
How's that going to look? Will I start writing in Java how I want something to be laid out in memory?
Yes and no. You will say that this is a value class point. So literally the token will be value space class voice point. You'll have an int X, int Y, or float X, float Y. Behind the scenes, though, you're not dealing with an object header. You lose semantic identity. That point can't be compared to other points as memory references. Instead, you compare them as values.
Right.
Is float X and float Y equal to float X and float Y? That's what's happening behind the scenes when you do equals.
Right, yeah.
Right? That's it. So you're getting the best of all worlds. You're getting, because I don't really care. It's not like I need to compare like if I have 2 floats, 2 points of the same coordinates, I don't care if they have the same memory. I just need them to be the same points, right?
Yeah.
They're small values. I need to just know that they point to the same place on the map, right? So that distinction is not useful to me. All I really want is the semantic identity, not the memory
It
reference.
always felt to me like pointer-based equality in Java was kind of a hangover from how C did it.
Yeah, and so you can create your own value classes, and those will just be, you can do equals equals, not dot equals, on objects, and it'll do the right thing, right?
And you don't have to define the equals method yourself?
I don't think you can. I don't even know. Yeah,
Good.
but this is still early days yet. We're maybe a year or two off, but the idea is with that world, you'll have these values that you can now pass around. And because remember, the single biggest thing you can do to improve your performance for things like AI and video games and graphics and all that is cache locality, CPU cache locality. The more data you can fit in the same cache registers, the faster it is to find that data and work with it. If you're constantly seeking and all this stuff. Same with any like a hard disk kind of arrangement. You don't want to like seek all over the disk. You want everything to be close together. So the same thing here. You want CPU cache registers to be near each other. You want them to be tightly packed.
You don't want to waste space on object headers.
Right, exactly. So that goes away now, right? And so you don't define how you want that all done. It's just done for you, right?
You've mentioned it 2 or 3 times now. Does this mean that Java is going after the games market? Are you implying that?
No, I'm saying I think it's much more that it's going after the AI market, right? But I can't speak to what the ambitions of the designers are. I can just say that were I designing a video game or a map or a AI TensorFlow kind of thing, yeah, like in Python, they don't have these distinctions. So they can't do these things. The only way they do is by cheating, by dropping down into C. So they have SciPy and NumPy and all that stuff. That's not Python. There's no such thing in Python that does a data frame.
Yeah.
Right? So this stuff is all, they're using high performance primitives in C code, but there's that marshalling overhead. Why can't we have that high performance code in Java to begin with? We could do the same in Java. You could drop down to native
There's
code.
long been a C API for Java, which
Sure.
is no fun to work with,
Well,
as I recall.
Even better, though. That's gotten better. So that you're talking about JNI, which is as you say, a rather hemorrhoid-inducing distraction. And it's the only thing I've ever seen where, in order to, the whole point, most languages, they want you to get purchase in that language, and so they make it easy to interop with existing code bases, which one presumed 30 years ago would have been vast amounts of C.
Yeah.
And now, I have plenty of code that it compiles down to the native C API, but it's not necessarily C. And Java still isn't great. Up until recently, it hasn't been great at leveraging all that stuff, right? And I think that's had 2 kind of interesting effects. First, remember, Java came out in the world of applets and the browser, embedded browser-based clients, right?
Yeah.
So at the time, the idea that I would have easy access to native APIs from my Java code was not something they were trying to encourage. You could do it in the rare instance you needed to, but it definitely would have compromised the then nascent and novel idea of write once, run anywhere, right?
Yeah.
So they never really encouraged it. They made it like, I mean, it's the only language I know where in order to use C from Java, you have to write more C. The whole point is to repurpose existing C and get off of the language, right?
Yeah.
But no, you have to write more C to write this glue code.
Yeah.
Right?
Python has that as well, though.
Yeah, and that's called JNI. So I don't like that. Most languages have an easy foreign function interface. Basically, I can sort of like a reflection API. I can look up symbols in the native runtime. I can look up native symbols in the load path, right? And then get the ascertain the shape of those symbols and then call them. Well, now we have that in Java since Java 22. It's called Project Panama. Right?
Okay.
So you don't need to write C code to call something that's on the. If you're on, I mean, come on. This is a trivial example, but printf. Why can't I just call printf, right? So Java now has this ability since Java 22. You can create a memory arena, which is basically you're mallocing some RAM.
Yeah.
And you can actually get the struct. You can get the layout of a struct in Java. And then say, okay, or you can describe this layout of a struct. You can say, this struct has these fields, and I want you to create a memory arena that is equal to the amount of memory that would be required for this struct. And then I want you to set this field to that value and set this field. So you can, in effect, reflectively interact with these types and then pass them back and forth natively, all from within Java.
And it will lay it out in the way that C is expecting, so this works.
But you have to do some hand-holding to tell it how to do.
Are you writing that hand-holding in Java? Or do I have to break out an XML file?
You write it in Java.
Okay.
But I don't want to even write it in Java, right? Because it is already written once, it's in C, and that seems like a perfectly reasonable way to go. So there's a tool called JLink, or is it JExtract? I forget. One forgets. It's JExtract, I think, or JLink. One of the two. You point that at your path and your header files. It'll dump out a Java peer. You add that peer to your class path, and so now for printf, I have a public static void printf function. I can import static, and it in turn calls the native Java code, the native C code for me.
And it just works.
Well, no, it works for the trivial stuff, yeah. But I wouldn't if you're doing, Microsoft COM, trying to get into Ole and whatever. Yeah, you can expect to fiddle with that, and you might be better off just trying to do slow, low-level Project Panama stuff instead of using this high-level code generator thing.
Okay.
But yes, that's the point. Anything you can call in a C ABI, you can now call from Java. Okay. That means Go, that means Rust, anything that compiles to that C ABI.
Yeah.
Right. And that's great. That's really good. That's the kind of thing I wanted a long time ago. And but to their credit, I imagine today, with almost certainty, I can install 99.99999% of all the jars I see out there and run it on any operating system I run it on.
Yeah,
that's Java. You can't say that with any other language. You can't say that with Ruby. You can't say it with Python. You can't say it with PHP. You can't say it with Perl. They all have half of them. Half of Python is native code. Well, whatever. Some ridiculous proportion that makes everything risky. I've got 30 years of Python experience. I learned it when I learned Java. Right. I love Python, but don't tell me that it's pure. It'll sit there and you'll. Again, we just talked about SciPy and NumPy. There was a time when that wasn't available on every operating system. And by the way, it's one of the operating systems these kinds of things are not typically on at the very beginning. Windows.
Yeah.
Because people are writing this stuff in a Unix shell kind of environment.
Yeah.
They're not thinking about the Windows users, right? They made it work in Unix. That's all that matters. But it's not.
Are you implying that, in modern versions of Java or forthcoming versions of Java, I can expect to write things like matrix multiplications of high efficiency on Windows and it will just work?
Yeah. So there's a special case for that. Yeah. We have Project Valhalla. That's the thing about which I just spoke. That'll come in, I don't know, nobody's promising anything. If it comes out in 5 years, I'll be grateful. If it comes out in 2 years, great. I don't know. No idea. Zero idea. But Brian Getz, Java language architect Brian Getz, assures us there's a working prototype and that they're just sort of polishing, I don't know, whatever. I give the team time to cook. They do a great work when they cook, right? But there's a contemporaneous with that. There's another effort called Project. Well, what's it called? It's just the Vector API. I forget what the project name was. It's the Vector API, and the Vector API is specialized support. It's not the old Java vector list type. It's instead it refers to matrices. Okay. Right? So you can do fast Fourier transforms and matrix multiplication and all the kind of stuff you'd need to do to build your own, say, TensorFlow, right? Like that kind of thing. And that requires, that's GPUs, right? That's specialized computing hardware for that. Yeah. And so again, with Project Panama, one could, were they so inclined, write native code to do that today. So you've already gotten out if that's really a thing you need to do, and it's been there for a year at least. Yeah. But even better, there's a Vector API. Project Panama is GA, but there's a Vector API that's not GA, but it's been included and it's been fairly stable for years now. It's a preview feature. Okay?
It's one of those things you just flag enable in the JVM you've currently got today.
Enable preview, exactly. And it's there, and the reason it's not yet GA, despite it being so darn stable, the thing has been around, I think they started talking about it before the virus, before the COVID pandemic, right? It's been around in some incarnation or another for years, right? Yeah. And last I heard, and I could be speaking out of turn here, but the last I heard was that it's basically good to go, except that they might have to change everything. And what I mean by that is the aforementioned Project Valhalla. Well, the whole idea is that, imagine like big integer, right? Big integer is a type in Java that gives you the ability to have high fidelity integers. That have like 1,000 places or whatever.
Yeah, sure.
Some huge number going beyond the limitations of what's that standard that discovered it? IEEE or whatever.
Yeah.
And all that, right?
What happens when you run out from 64-bit?
Precision, yeah.
Right, yeah.
Exactly. All that stuff is specified in IEEE, but some people want to deal with, like in financial contexts, 1,525,000, like 20 numbers and then 0.275 has to still mean something. So or at least without the point, right? If you're doing an integer, that still has to mean something. It has to be preserved. So we have a thing called big integer. But why couldn't that be preserved as a value type, right? Why couldn't that be reified, right? Same thing for I talked to you about list of int. lists of integers. Why couldn't it just be a list of ints? Why couldn't I have an array? Why couldn't it compile down to an array of ints, even though I'm using a list as the wrapper? Why couldn't that be a value type?
Yeah.
Right. So there's all these things that'll look better and feel better once Valhalla lands. So they've released this vector thing. You can use it, and there's already been preliminary tests, and notably in the 1BRC challenge.
Oh yeah, Gunnar Mauling's how fast can you process 1 billion rows?
1 billion rows of weather station telemetry data. Yeah. And the first and fastest entry there is Thomas Wertinger's entry. He's the creator of GraalVM, and it's pretty good. But there's like one in the top 10, maybe it's like number 8 or something. And that number 8 is using the vector API. I forget the number, but it's one of those top 10 ones, and it's using the vector API. And it's really fast, right?
Quantify that.
Well, it's, what do you mean?
Are we talking seconds, minutes?
Oh, well, it's like 1 point, it's like 2 seconds, whatever.
2 seconds for 1 billion rows.
Yeah, billion, one with a B, right? The first fastest one is 1.5 seconds, isn't that right? 1.5 seconds?
I saw the league table like the second day after that challenge came out. And
I think the first one is 1.5 seconds, something like that. And then the rest of them all fight for staying under 2 seconds, right?
It still kind of blows my mind that we can process 1 billion records in a couple of seconds in Java.
Yeah, and that's without, so the first 20 odd, almost all of them use exclusively the GraalVM native image compiler, which will give you some benefits, particularly in their area of startup time, right? But the vector API allows you to optimize your runtime, right? You can deal with less RAM and deal with less data. But the problem was, at the time of this competition, ran in January of 2024, so more than a year prior, there was no support for GraalVM native images and vectors, right? So the preview feature is an OpenJDK preview feature, but it wasn't unlocked for the native image capability of GraalVM, even though you could use it as part of the OpenJDK distribution that GraalVM ships with.
Right.
You just couldn't use that as a native image, an AOT compiled native image.
All these like preview features, but they don't necessarily all work with each other.
Right. So now apparently they can. And so Thomas, I think he told me that were they to run the comparison again today, it would be faster than his entry, the fastest, right?
We should get on then to talking about Graal.
Yeah.
Because we should outline what Graal is and why that's important.
Oh, just wanted to say.
Oh yeah, sorry.
Wrapping that thread up, you've got things like virtual threads, which are far, far more elegant and less ceremonious than async await, right?
Oh, okay.
Far less bureaucracy, far less ceremony, far less nonsense. It's just, I change the executor type in one place in my program, and every thread that's spawned from that executor is now a virtual thread. I get the benefit of non-blocking I/O without having to litter my code with async await. So this isn't just as good as TypeScript or Python or whatever. It's way, way better, right? We have auto typing, we have var. Right. Again, you can point to something like TypeScript and say, well, I don't need semicolons. This is the level where we're starting to qualify, well, Java is ceremonious versus not, right? And it's a nonsense discussion to have, right? People don't actually care about typing semicolons. It's just not a thing. If the compiler can tell you exactly where you screwed up, then there's no brain power required to get it right. So just do it. Who cares? And quite the contrary, you can make all sorts of weird mistakes without semicolons in JavaScript and TypeScript.
I'm not excited by the semicolon argument at all. We can skip over that.
That's my point.
Yeah, I mean,
the level of pedantry we have to get into to find real places where Java is actually markedly different than these other languages. Then you get into things like the collections, and I would say yes, we're 100% aligned, except there's a difference there, right? The story in something like a Python or a TypeScript is just not performing collections. It might be fun to use, but it's not performant, right? And so then you get into like, well, I have to use a C extension. And I would say, okay, fine. But even there, we're going to fix our value types before they fix their not performant collections. So then the question won't be which is more ceremonious. It's just they're both equally not ceremonious, and then which one's more performant? And I think the answer already is Java. It'll be more so in the future. So I just think, again, ceremony is just not a thing as much as most people would like to ascribe it to. It's these corner cases, like I want to have a Lambda with 20 parameters. Oh, okay, well, can extract out an interface. But again, that might have been better designed as an interface anyway. It's clear there's got to be some rhyme or reason to it,
Okay, I'm going to have to challenge you on this.
Sure.
I was going to avoid it, but you gave a code demo earlier. in your talk.
Oh yeah.
And you still had the ceremony of, there was one class when you started and it's 7 directories deep. It's like source, main, Java, com, example.
Yeah, you're right.
So there are still ceremonious conventions, if not enforced by the language in the Java world.
They're definitely not enforced by the language. I think, and that's where I agree. So there's no reason in Java I couldn't just have a main class and just compile it in the same directory, right? In practice, that's not what most people do. And if you look at any Node project or any Python project, they're going to have multiple directories for the source code,
that's fair.
For the libs, for the vendor modules from Go, there's always going to be folders. But the way people work with Spring usually is they go to start.spring.io or go to file new in their IDEs, and that generates a project, and that's already done for you. And so,
And why break the conventions?
I mean, it's just been there for 20 years. It's a Maven convention. It's not Java, right? Maven is a build tool, and that's just, even the competing build tools honor that arrangement. It's just, it works. You have a folder for your source code. In that, you have your test and your main code. And by the way, that arrangement assumed that source wasn't the same as main, right? This is not novel now, but back then you had a folder for your source code, then you had your code. This is 2000. Did you have tests? Well, we're not that hip. We don't do tests. That's a new thing. That's what those weird kids are doing.
Yeah.
Those agile kids, they make no sense. But now we just assume you're gonna have tests.
Yeah,
I don't take it for granted. I just think it's a really nice. So it's source main and then source test.
Okay, I'll buy that. You raced through a point I find very interesting: the async await. You don't need it thing.
Yeah.
Can you go through that in length
Happily.
for me?
So was it C#, I think, or was it JavaScript? I don't know, I forget. But one of those two languages wanted to find an easier programming model to describe the composition of asynchronous things. Yeah, and so I think let's take JavaScript for example. JavaScript was written with one thread in mind, the browser thread, the render thread, and that limit that I don't know if it's a limited that design carried over for Node. Right, and so when Node came out in 2009 or 8 or whatever it was, everything was callbacks.
Yeah,
right, and you get these deeply nested callback hierarchies, right, and people bemoan the situation.
And people talked about callback hell as though they lived there.
Well, to their endless credit, the JavaScript team then stumbled upon the idea of a promise, right, and promises are basically the equivalent of what we have in the reactive community, in the Java community, called a publisher. So in this way, a promise, you can say, the thing over here that does some processing returns a promise, which I can then call .then, and in the then I get a context object, which is the result of the previous operation. So instead of having deeply nested, I can just have .then, and it just goes straight down, right? Which is also, and you can do filter, you can do map and flat map and all that kind of stuff, right? So that's a lot nicer. But still, you're very much dealing with a chain of lazily evaluated things, right? These are operations that haven't run yet. By the time you get to the end of that line, nothing has run yet. There's a terminal operation that then initiates it, kicks it off.
Yeah.
And so that asynchronous sort of component model, that composition model rather, is,
a big improvement on callback.
Sure.
Not the end game.
Not the end game. And in the Java community, we have reactive programming, which does, I would say it's better, but it's the same thing. Okay, and there's more edges to it certainly than in the promises land, right? So then I don't know, 15 years ago, I think it was JavaScript or C#. One of those two came first. They introduced, I think it's C#, but I'm not sure.
I'd be surprised if they stole it from another language from the 70s that we forgot about.
Yeah, that's fair. Yeah. Okay, so async await. And so here you have a function in the language. You have a function that returns a task as opposed to a promise in C#, right? You have a task. And a task is a task of Boolean, or a task of customer, or a task of T, where T is your generic parameter.
Yeah.
And the language is written in such a way that now the thing that would have otherwise been a promise, or a very fancy future, that promise you can actually now call await. So you can say auto my result equals await, and then call this function that returns a task.
Yeah.
And then if you unpack if you look at the value that's stored in the my result variable, it's not task of T, it's just T, right?
Yeah.
And
this is the trick where you say promises are really useful, but they'd be even more useful if we put some syntactic sugar over building and extracting from them.
Exactly. Right. And so I can see why that's useful, but in order for that to have worked, your function has to be marked with async. So async and then you return, or it has to return a T, right? Either you call another function which returns an async value, or you return a T directly, a task of T directly.
Yeah.
Right. So you're promulgating this task / async all the way down.
If you call an async function, you have to be async.
Yeah.
So your parent has to be async and so on all the way.
And it creates this chain. And what is this doing behind the scenes? Well, imagine I want to read from a network socket in Java. You say I have an input stream. The input stream gives me it represents a perhaps as yet resolved buffer of bytes, and I start reading from the bytes. Well, the network socket is not going to give me all the bytes instantaneously. It'll give it to me as they become available. So maybe the server's not yet done loading the page, or maybe the network is a chat client and they're still typing messages. So I haven't gotten everything that they've said because they're still typing, right? And there's a realistic understanding of what's happening here. But as I wait for those bytes to come back, I call input_stream.read in the JVM. I'm waiting. I'm stuck. I'm sitting on a thread.
Yeah.
Right. And that thread is inaccessible to anybody else in the system. I'm bogarting it for my own use, even though I'm not doing anything besides waiting. The same situation exists in C#. It existed in C#, where I'd make a call and I'd be sitting on a thread. And threads are limited. They're a precious resource. They're not infinitely available.
Yeah.
So this is where you get the task stuff, right? Okay, I'm gonna ask for the bytes, and as they become available, I'll get a callback.
Yeah.
Right.
So now it's some internal scheduler can park that thread elsewhere.
Right.
Yeah.
And then so tasks that even before async wait, you have this tasks notion. You're saying I'm waiting for call me when you're done. That's it. It's a asynchronous reactive thing, as opposed to it's pushing the data to me as opposed to me pulling it. Yeah. But the benefit is that whilst I'm waiting, I'm free to continue my thread of execution and move on to another thread, or put the current thread back in the thread pool, and then while I'm waiting for that thing, it'll get resolved asynchronously somewhere else.
Right.
And then when it's done, my logic will get run, put on a thread, and run to handle the results. So that benefit is I'm not sitting on the thread, right? But I still have to deal with this asynchronous style programming, right? So then here comes async await. Now I say auto my value equals await this function, call this function.
Yeah.
And then behind the scenes, what's happening is it's rewriting the code so that if you actually put a breakpoint on the thread in which it's executing before you call that function, and after, you might see that the thread name has changed, right? So I said basically the compiler wraps up the rest of the continuation. It wraps up the rest of the code in that method in a continuation, and it calls it after the bytes have come back. Yeah.
And it might be running on a different thread by that.
Very much. Very, very possibly. Yeah. And that's nice, because that means that it wasn't stuck on the current thread while you're off waiting for bytes that may never come. If you're waiting for 5 minutes, the last thing you want is for that thread to be unavailable for anybody else in the system, because there's only, again, a precious limited number of threads in the system. So that's async await.
Yeah.
And the async await hides, it spackles over this async callback centric programming model, or this .then style programming model.
Yeah.
Right. And to be fair to C# and Python and JavaScript and TypeScript and
Rust
they
does async await. Yeah.
Oh, good. Finally. Okay. I thought everything was still using just Tokyo. Yeah, it's nice. So yeah, it finally, this approach is useful for anything that could take a little time. Right?
Yeah.
Like in theory, if you're doing a Fibonacci series and you want to do that in another thread, that you could do await, you can await that, right?
Yeah.
Fibonacci series, of course, is just it's CPU bound.
Yeah.
You're not really doing anything. You're still working on a CPU. You just decided to do it in a separate thread, which seems pointless to me. I would just do it in the current thread since it's CPU bound anyway, right?
Yeah. Yeah.
Actually making that slower. But the real use case that most people struggle with is I'm waiting for bytes to come back. That's I/O. That's not CPU bound. That's just idle time.
Yeah.
That's like doing thread.sleep.
And sometimes it's locked on a user on the other end, which is almost infinite waiting time.
Sure.
You've got no control over it.
There's no reason to just be sat there stuck on a thread, especially if you're not doing anything on the CPU. And if you are doing something on the CPU, you can just use the current thread.
Yeah.
Right? So Java took a much better approach. They said, okay, what we want to make sure doesn't cost people is I/O. That's where we want that to be non-blocking. Okay. Right? Like if it's CPU-bound work, then it should be blocking. Otherwise, you're just wasting time switching threads for no gain. You're still going to take time out of the CPU. It's just going to be on a different thread, which means copying the current stack over and moving things around
pointlessly,
right? Pointlessly. So with I/O, if I'm just waiting, that means that thread could be freed up and somebody else could use it, and I've expanded the total availability of the CPU to code on the system, right?
Yeah.
So with Java, they said, okay, we have this new mechanism. You need to give the runtime a queue, just like with async await, that it's okay to then create a continuation out of everything that succeeds as blocking operation, and then call it when the blocking operation is finished. The queue, in this case, the clue, the hint, is the fact that it's running in a virtual thread. It's just a thread, looks exactly like regular threads, Javalang thread. They're both Javalang threads. One's a virtual, one's not. If you're running in a virtual thread, it automatically does this for you. You call a blocking operation. If that blocking operation is thread.sleep or input stream.read or output stream.write, it just waits in a different, it wraps up everything, puts it in a continuation, and calls it once the blocking thing is finished.
Do you know how this is working under the hood, such that you don't need to write async await, even though essentially you're dealing with the same thing?
There's only a few, again, there's only 2 or 3 places where these non-blocking operations, these things should, anywhere there's I/O,
Right.
the runtime can detect that you're doing that. It knows what I/O looks like at the core of the platform, and it has hooks there saying, okay, as soon as these bytes come back, I've got a continuation that needs to run, call it.
Is that happening at Java,
Yes.
the language level, or JVM, the virtual machine level?
JVM level. There's this new thing called a continuation underneath the hood.
Okay.
You can actually get to it, I think, but most people will never need to do that, right?
That's why they can detect on only a few places, because the virtual machine doesn't have that many operations.
Right, but the only, you say only a few places. There's 2 places, I/O and thread.sleep, right? There's no such thing as a non-blocking Fibonacci series or cryptography. That's CPU bound. It should be on the CPU. If you want to do that, you can put it in a separate thread and run it yourself.
Surely the virtual machine has a few different I/O calls.
Sure, but they all go down to the same core, right?
Okay.
Right. There's only, at some point it's native code, so we just trap that hook basically.
So you can get because what we've always wanted as programmers is the ability to write asynchronous code, but have it look like regular code.
Yeah.
And you can get all of that without even function coloring for async await.
Right.
That's cool.
So this is not just as good as those other languages. It's far better. And this is actually, the only other language where I've ever seen this is Go.
Okay.
Go does exactly the same thing, but to be fair to them, they did it 15 years earlier or 13 years earlier, and they didn't have to deal with the backwards compatibility of the existing solution.
Yeah.
From the get-go,
you'll be the first person to ever do that, Joe.
From the get-go, they had, this approach that the blocking I/O code that you wrote was actually non-blocking behind the scenes. Right? So you write very simple imperative programming 101 style, while input stream.read does not equal -1, keep reading, right?
Yeah.
Like that code is now non-blocking. It just is. You don't have to, you're not dealing with async, you're not dealing with threads, no futures, no completable tasks, nothing. It just is non-blocking. And then Go does that for everything. There is no backwards compatibility to maintain.
Yeah.
So Java somehow did it almost as concisely. You have to create one executor object or one thread pool or something like that, right? Whatever factories the thread, you can actually just call a new thread if you want, and then set it to be a virtual one, right?
Okay.
You can say thread.of_virtual, thread.capital thread.of_virtual parentheses dot, unstarted, and then pass in a runnable, and that'll be the same thing. But most people in most contexts will have an executor, so you call executors.new virtual task executor or whatever, and you get an executor, and then you can submit your runnables to that. Well, it's exactly the same Java util concurrent runnable you'd use 20 years ago.
Yeah.
And so you just change the definition of that one executor, and everything else that runs on top of that is now in virtual threads. And since most services are I/O bound, that's free scale.
Yeah. It's impressive they've managed to retrofit that. I'm sometimes impressed they've managed to put anything new in Java, but the scale of new Java.
They do it with diligence and care. So again, this Valhalla is, why couldn't Java be on par with SciPy or whatever, NumPy? That's the vector API. That's already here. You can try it out, and it's good, it's fast, and it's clean and nice. What about Valhalla? Why couldn't Valhalla be used for, Valhalla is like, you don't even need specialized hardware in some cases. You know what I'm saying? Like some operations just become way, way cheaper. They've already done tests on, like, if you did n times x, x times m, or m times n. There you go. N times m. Nancy times
Miami.
Mark, whatever.
We're in Miami right now.
Miami, yeah.
Let's say
Okay.
Miami.
N times m. I'm trying to pronounce it so you can hear. Why can't I do x times y? There you go. iterations. For each of these, then for each of those, do multiplication and do some processing. Well, they did. I saw Brian Getzey talked about it, and he said it was like 3 or 4 times faster than just doing it on the JVM already. That's just Valhalla. That's not the specialized vector API. That's not nothing else. Just using regular Valhalla for free. Code that did that before in regular Java just becomes faster. That kind of stuff.
Yeah.
And we haven't even gotten to the benefits of like, okay, well, now I've got a list of int, right? And by the way, another thing that falls out of having nullability, having primitive types that are values that in non-primitive container types like lists. Another thing that comes out of that is you get eventually you have to answer the question of, well, okay, integers are nullable since they're objects and all objects can be null.
Yeah.
So a list has to support nullability. But what if I have a list of int? How do you do an int that's null?
Yeah, because the primitive types aren't nullable.
Right. So if you introduce primitive types, don't you need to account for what that means? What does nullable look like if you have a value point? Is that nullable? Right. So then you get into, okay, well, Java needs nullability specification, right? And that's coming as well as part of Project Valhalla.
Specification of like how everything is nullable, or a specification of some things aren't nullable, and here are the rules.
So normally you say that this is nullable and that's the default. That's the exception. Nullability is the exception and not null is the default. But since we're doing it retroactively, everything is nullable, and you can annotate with an extra, maybe a question mark, an exclamation mark, or something like that. They'll have to answer that question of, okay, well, can I make this thing not nullable?
Right? So I will finally be able to have value. Finally is the wrong word because that's a keyword, right? But I'll at last be able to say this field can never be null.
Yeah.
I'd take just that.
Just that. I mean,
I'd take in Java.
So that won't even be in the first tranche of support, though, sadly. Valhalla will deliver value types first.
Okay.
Then they'll introduce nullability specifications. But it's all in the sort of like Brian Getz is talking about it, right? But all these things are, again, they all sort of go towards that. If I want to do this correctly, we do it incrementally. We introduce these features piece by piece, and that's what they've done with Java 17 to 21 was, I thought, kind of a masterclass in exactly how to do that. They introduced these little tasty morsels of syntax improvements that culminated in Java 21 supporting something called data-oriented programming. I mean, data-oriented programming is the second biggest thing they introduced in Java 21. The first one was virtual threads, right? Oh, even there, the virtual threads. I'll come back to data-oriented programming, but virtual threads, they introduced virtual threads, and they said, okay, for these blocking operations, you don't have to do reactive programming, you don't have to use Java NIO, you don't have to use netty, just use regular input stream and output stream. Things will work. Asterisk. And the asterisk is when you do, if you do input stream.read or output stream.write or thread.sleep within a synchronized block. So you say in the language, hey, I've got a synchronized I've got a semaphore, I've got a lock on. There's no thread can enter this block.
Oh, I haven't thought about this in years. This is Java's feature where you can say this code block is
exclusive.
Yeah.
And so that monitor is held by the class. It's held by the thread on which the code is running, right?
Right.
Well, that thread used to be a C construct behind the scenes. The JVM has a C type that holds the monitor, and that was bound to the current operating system thread.
Right.
Well, now you've got 2 kinds of threads in Java. Again, virtual threads, which are green threads or fibers. And by the way, those are not backed by anything on the operating system. So you can create millions of regular virtual threads, millions and millions on a regular paltry JVM, no problem.
Right. Yeah.
And they will get mounted onto carrier threads to get a chance to run. Those carrier threads correspond more or less to operating system threads that we saw before.
Yeah.
Right? And those are still there. They're just slower and less scalable. So now you've got these virtual threads, and they are not mapped to the C code for the thread, and they don't have their own monitor.
So how do you get the exclusive lock?
Well, so for Java 21, they couldn't do it correctly in time. So they introduced something called thread pinning. Basically, if they detect that you're doing a synchronized lock around a blocking operation that would have otherwise been made non-blocking in a virtual thread, they'll just pin you to the current thread. So you get none of the benefits of virtual threads.
Right.
Which is fine. That means that nothing breaks. Everything that has ever worked still works.
Everyone gets to move forward, and things don't get worse. They might get better.
So they had to refactor the gnarly and very, very, messing with semaphores and memory and C code is not my idea of a good time. So they reworked that. That's fixed now in Java 24. So you can do, and by the way, think about what that means, by the way. I said you can't do synchronized around a blocking operation. When would you do synchronized, like when would you want to monitor so that you can then read memory from another web server? It makes no sense, right? Like you wouldn't do that anyway. But if you did, that would have broken.
Yeah.
You wouldn't like synchronization on the current thread and the current JVM doesn't mean the state over there is somehow exclusive. That's nonsense. I'd do the IO somewhere first, and then when I in a hot path in my current JVM, when I had to ensure that I'm mutating one little thing and it had to be within a synchronized block, I'd do that there. I wouldn't do input stream.read. Right?
Yeah, that makes more sense.
So it was a bug, but they made it so that it didn't affect people, it didn't hurt them. It just degraded the behavior to what we had before.
Yeah.
And then it was a weird one. You wouldn't hit it if you were writing your code with any sensible sort of approach. You would have hidden it in the first place because most people don't do I/O inside of a synchronized block. I mean, that makes no sense.
Yep.
And then even if you did do that nonsensical thing, it's fixed now in Java 24, which is GA and already out for months.
How did they fix it?
They just rewrote the code so that the C code now has a monitor that's moved up a level to the virtual thread or to the operating system thread.
Okay.
That's all. It was just gnarly C code. They knew how to do it. They just didn't want to like take big swings of that, making sure they proceeded very, very carefully because memory models across C runtimes or not runtimes, languages, platforms are different, So that's fixed. So there's one more asterisk. But again, between those two things, I reckon like 99.99% of all people that are ever going to use threads will get benefits now out of virtual threads for free. You just upgrade and set that. By the way, I mentioned using executors. But if you're using Spring, you just set the property, spring.threads.virtual.enabled equals true, and you're done. And then we'll set the executor up for you. So again, we're talking one property, and you get really good scale. Okay, so the third and final case where you might have some issues is in class, if you do native code. So if I call into JNI, like we talked about earlier, I have a Java code, and I'm going to call native code, but I'm doing so on a virtual thread. Well, that native code causes thread pinning, right?
Yeah.
Even though it's a blocking operation, even though it's taking time on the CPU, or taking time but not using the CPU, right? And so they still pin on that. So unless you're like, that's not going to affect most people, but it will affect some. And the reason I say that is class.forename, the thing used to reflectively create an instance of a class, that requires some native code, and apparently that's still affected.
Okay.
But again, most people aren't doing that kind of goofy low-level metaprogramming. Certainly not in the context of you would do that once, one assumes, not every time you process a request coming in,
Yeah.
That kind of thing. So
this makes me wonder, unless you're about to go somewhere else.
So finish your thought, yeah.
I'm just wondering how much of the innovation you think that is happening in the Java world is at the language level and how much is at the virtual machine level?
That's what I'm saying. The language level is great, and I live for that, but the real crown jewel, the reason that there's been 30 years of innovation, and I reckon, I don't know, nobody's ever showed me anything, but just do the math, right? We've got Sun and then Oracle, and by the way, Oracle's been this shepherd and steward and the carrot feeder for Java for a lot longer than Sun has at this point.
Yeah.
Right? And they've done a fantastic job. I mean, there's how many different companies, how many thousands and thousands of full-time people thinking about this stuff all year from all around the planet. Alibaba, from IBM, from Oracle, from even people at Broadcom, we help send ideas, and we interface with the Java team. I mean, all around the world. How many billions of dollars do you think that human power is worth? I don't know that there's anything else that has anything close to that, and it's at such a professional level too. Linux is the only thing I can think of where that many people from so many different contingencies have come to bear on one particular problem for so long.
Yeah. I wouldn't be surprised if by sheer numbers Java's larger too. Then there are more Java programmers than there are people who've ever contributed to Linux.
Oh well, sure. If only because the barrier to entry is so much lower, and that's not just a slide at Linus Torvald. That's the technical barrier to entry of writing C code fit for the kernel versus writing code that can be used in a Java context is different. So all that I'm trying to say is that's an amazing, amazing piece of kit. You can make fun of the works of the Java syntax all you want, but never, ever, ever doubt that the reason people who have choices, right? The largest organizations in the world have choices, and most of them use Java at scale. There's a reason for that, right? Every single one of them, except for even Facebook, their data processing pipeline, they did the worst thing. They made the mistake of using PHP. Then, rather than admitting their mistake, they doubled down and decided to turn PHP into their own bespoke, bug-ridden, half-implemented version of Java called Hack, aptly named, right? But everybody else just said, nah, I'm using the JVM. This is bulletproof rocket sauce software. I'll use that. It'll get me to production. And it did.
Yeah.
So, there's a reason.
Yeah. You've thrown me off thinking about PHP now. I've got
data-oriented programming.
Yes. Yes, of course we're going to talk about that.
That was Java 17 to Java 21. They introduced a bunch of small things.
What does data-oriented programming mean to a Java programmer?
I wonder. I'm actually keen on knowing what it means to everybody else too, because the way it's been explained to me as a JVM developer was sort of the language, the arena of a server-side application today has changed. Increasingly, the messages that we send into and send from services are the way we express changes in the system, rather than introducing new deeply seated hierarchies of abstract types, right? So if I want to change something, if I want to communicate from one part of the system to another, that something should change, I don't create a new implementation of something. I send a message via REST, via RabbitMQ, Kafka, gRPC, RSocket, whatever, GraphQL. They're all messages, right?
Data has become the language of communication rather than invocation.
Exactly. And so the language has to be more adroit there. It has to be more elegant, more concise. And so there's a number of things that make that experience just better, right? Pattern matching. Mm-hmm. Smart switch expression, so you can do you can match on types in a deep structural way.
Didn't you only used to be able to switch on numbers and strings or something?
Now you can.
We finally moved away from that.
You can. Yeah, you can. Well, you can switch on. Yeah, I think you can. Yeah, but you can also. Yes, you can, because you can also do pattern matching there. So I can actually say not just that case. This is a shopping cart, but I can actually say this is a shopping cart with a customer inside of it. Yeah. I can match the pattern of the thing, and I can extract out that result.
Yeah, right,
in the block. So there's that smart switch expressions, pattern matching, sealed hierarchies, which allow
hierarchies.
Yeah, it's a new, more granular visibility, not visible, protective modifier. So I can say this type. Imagine I'm working in a highly regulated financial services context.
Yep.
You don't want Sam Bankman-Fried coming along and creating a new loan implementation that has a no-op, that does no validation for where the transfer is going, right?
Yeah.
But there's going to be secured loan, unsecured loan. Those are the only two implementations in this whole code base, and the compiler should bark if that is ever not true.
Okay.
Right? That allows first of all, that allows the compiler and the runtime to not have to worry about undetermined, as yet unknown polymorphic subtypes that it has to worry about dispatching to. But second of all, I can be sure that if somebody violates that premise, then the compiler will bark.
What are we saying? That you can mark classes as closed for extension?
Yeah. I can say this type, I can say this is the interface, and I only permit the following subtypes.
So the interface will define who's allowed to use it?
Well, it's not the interface, it's the actual abstract class, but yes.
Okay.
Or the super type, yeah, the parent type is the thing that delineates, or it permits the subtypes.
That's an interesting thought. I don't think I've encountered that in another language.
It's interesting. I reckon you can get, other languages have the ability to seal the types. We get the same sort of effect. It's just a roundabout way of doing it. And the benefit is that it's one of those rare instances like virtual threads where the result is better for your runtime efficiency and less code. It's just it's so nice and that's the benefit of using a runtime language like Java. You upgrade to new Java, you get better performance. That's rare. You don't normally can't upgrade to a new thing and just get free performance gains that you can tell management about. Look what I did.
Yeah.
I saved 10% off of our RAM budget, or I saved 15% off of our scalability budget, or whatever. Made it faster.
Occasionally, but usually it goes like if we make things faster, they look worse and they're hard to maintain.
Very rare. Yeah. And we're getting a lot of those right now in Java. So Valhalla will be one of those things where I just paint my code with the value keyword, and I'm like immeasurably large gains there. Virtual threads. Again, I showed LLM stuff in my
yes. Let's talk about because Java's making a move on the AI world.
Yeah, right? I think it's ours to take. I think there's a look. I mean, 90% of organizations out there have software in Java. And I'll bet a lot of these organizations, especially we're at a Modern's Code Remix conference here. These are all large. You've talked to some of these people, right? It's large organizations, financial services, governments, insurance companies, media, startups too. But my point is, everybody, they're all using Java at scale. And the reason is because it works and it's a steady hand. But that's where your business logic is. That's where so many people have the business logic. It's where so many people have their data. It's not in the code proper, but it's being guarded by services written in the code.
Mm.
And that's where one imagines it would be most useful to hang off these AI integrations, right? To expose as agents these services, right? Or to expose as MCP services these services. Right?
But yes, I totally agree that if you've got lots of Java already and everyone's jumping into AI, of course you're going to want some kind of support. But are there Java or JVM specific things, or are you saying there's a lot of libraries being built?
What do you mean? Java?
Are we saying that somehow the language Java is changing to adopt AI, or are we saying the tool, like things like Spring? Are you saying that Spring is investing heavily on those utilities?
The answer is both, and that's, the first half hour of this conversation is all about those changes that will serve us better. So for the moment, Java's strength is in integrating existing LLMs, which, since most LLMs just have a REST API, isn't hard.
Yeah.
Right? And Java's got, say what you will about Java, but we can do integration like nobody else, right? That's the bread and butter of every Java program ever written, is the glue code. Pulling together all these different siloed data sources and syncs and all that stuff. So this is just more of that. This is why the largest microservice systems are all in Java, right? If you want to build REST APIs and services and all that, they're Java. So okay, fine. Now we got more of that. Okay. But I would also argue that the language proper, again, with Valhalla and the vector API, these things will make Java more suitable for the other side, which is I want to train a model.
You think we'll actually be training models in not C or Python, but Java?
Why not? Well, it'll be more performant to do so in Java. There's already even LLM 3 or something like that. There's actually an LLM you can use to completely run in Java, and it compiles to a GraalVM native image. It's a single source code file, right?
We have to talk about Graal too in more detail.
Yeah, and that native image is, you can run a model faster than you would with like a llama. It's already there. That's not a question. That's today. Really? And by the way, that's using the preview feature for vector APIs.
Okay.
And GraalVM, right? Now, fast forward a few years, here comes Valhalla. We're talking about really interesting opportunities here. I don't know why it wouldn't be that way. And it's not hard to, the nice thing about the AI is that you can dump in the source code from Python and have it generate the Java. The tools the AI gave us the tools to translate our own way out of it.
It's like that sounds like AI is betraying its roots.
Yeah, well, a little bit. It's okay. Or we can extend from it, because again, we have easy integration with these native libraries as well with Project Panama. Either way, this world is something in which we can all partake in. I think Java is really well situated. Okay, performance-wise, scalability-wise, efficiency-wise, integration-wise.
Okay, I buy that. Then tell me something, because your day job is working for Spring. Right?
I love Spring, yeah.
So tell me something about the way Spring is evolving too. Starting with AI, but...
Oh, okay. Your check is in the mail. Thank you for that. So May 2025, we'll have Spring AI 1.0. Right, Spring AI is this umbrella project that we built, and we set about in 2023. I don't know. It's been a long time running and coming, and that's because you might have noticed the AI people won't sit still. Just tell them to shut up and sit still for a week, and we'll be okay. But it's finally going GA after so many years of iterations. Right, we're all very excited. It's been used already. People are using it out there, but it's just not GA. It's not 1.0 yet. It's always been, milestones and snapshots and whatever. And like, for example, we were, last November, most of us on the planet were just sitting there enjoying our November. Some of us were enjoying turkey, right? Not Anthropic. Anthropic, one assumes they had their turkey too. I don't know, whatever. But the point is, Anthropic also released this new protocol called MCP, Model Context Protocol.
Yes.
Model Context Protocol, you might have noticed, is just everywhere. There's all sorts of MCP implementations. It's a protocol that models can use to reach out and talk to tools. And when I say tools, I mean utilities.
Is it fair to say this? You were saying like calling an LLM is probably just REST. Is it fair to say that MCP is, let's put a proper formal REST spec?
But for it's less of a spec. The magic here is that the model, the LLM itself, is the thing that invokes the MCP service, right? Okay. And so you don't need a schema for that. You don't need WSDL. You don't need JSON API. You don't need
SOAP.
SOAP, yeah, that's WSDL, right? You don't need any of this nonsense. the model knows what the shape of a thing looks like if you just tell it, right? And you export the signature. So we were really intrigued by this specification, and it's become, again, there's thousands, tens of thousands of MCP services. There's MCP services you can use to like run Blender 3D and to render scenes and do music synthesis and other apps. And there's integrations for every platform out there. All the hyperscalers, all your platforms as services, all your, I mean, even GitHub and Microsoft separately and Office 365, they all have MCP services, right? There's MCP services for everything, and that's not already here. That's already here. It's already out there, right?
Yeah.
And so the idea is you point your AI model, and it's not just Anthropic, though they innovated and created the spec. It's become a thing that all these different vendors have announced support for, including OpenAI just a month or two ago. They said ChatGPT will support these as well. And so now you can give your model the chat box, whatever model it is, be it ChatGPT or Claude Desktop or Gemini or whatever. One imagines all these things will eventually support MCP services. You can say, hey, I want you to have access to this MCP service, this one, and this one, and this one. And now you go to your chat model and say, hey, look, we have an MCP service for Spring Batch, for example, right? Yeah. You can say, okay, how far along are my Spring Batch jobs? Great, okay. And you can say, oh, well, it looks like it's not going fast enough. Deploy a new instance on my cloud platform. Star Trek.
So in one sense, this is like integrating retrieval augmented generation into the model, in that the model isn't just baked once and that's it. You can now add in connectivity to other things.
So RAG does that. RAG extends the data set, but this is tools. This is verbs, not data, not nouns.
This is the ability to say and go and do something.
Yeah. And you have executive command, right? And obviously it'll be up to you to add these tools to the model of your choosing, right? We're not going to give it root level access to your hard disk if you don't want it, right? Yeah. But the point is you have this capability now, and you can bake it into your applications. And so we were so intrigued by the specification that we went out and built a Java SDK, which was so early and so good that it became the official Java SDK for MCP. So you go to modelcontextprotocol.io, which is the website for the project from Anthropic and the group around that. Yeah. Ours is the official Java SDK.
So the Spring one.
Yeah. Well, it doesn't. So we refactored the code, so it doesn't say anything about Spring. It's just a generic Java only SDK.
Right.
Then in Spring AI, we provided integrations rebasing on top of this new, now extracted Java SDK.
Right.
So you can use it directly if you like, but I don't know why you would. You can use it, but in theory, if you're using the MCP support from any other technology, it'll be using our core SDK support, right? Okay. We're not forcing people to use Spring AI, but why wouldn't you, right?
This is tricky in a podcast because you don't get any slides.
That's okay. I don't do just. Do you see slides?
No. But just give me a sense of what that looks like to me writing Java. What is it that I have to do to say I'm connecting this model and this MCP server together in my web app that I'm writing? Or
so okay, on the server side, I want to export tools. What are tools? They're methods. They're functions, right? That's the only. It's like RPC. So I have to export some tools, and you just annotate those methods with @tool, provide a human language description. It's literally description equals, and then this function does A, B, and C so that I can do X, Y, Z, whatever.
Right.
And you annotate the parameters to that function with tool param. Okay. You'll define one bean, assuming, by the way, you've got the Spring AI starter for MCP server on there on the class path, and you've got the web server there.
So I do the dance of jars.
Well, you just go to start.spring.io, choose checkboxes, hit enter, and you're done. Okay. Right. Like. Then you're in the Java code. I've got a class with some methods I've annotated with @tool and @tool param, right? I need to create one object of type method tool callback provider. And all that does is you give it a pointer to the objects that you want to export. Because you might have 10 tools, but you only want to export 3 for now, or whatever. Yeah. So it's up to you to decide which of those things you've described should be exported. Start the program, you're done. Now, you're in the client, you're in another service, you're in an AI chat box. Well, actually, at this point, you might already be done. Actually, that might be it. You might, if you're talking to a like a IDE, like Cursor and C-Line and all these things, a lot of them have MCP support, right? So you can just point them to these services and say, hey, these are tools you can use when you're helping people do editing code or whatever, right?
Right, yeah.
Okay. But if you want to integrate that tool into your AI code that you've written that's using a chat client, right? You can do that as well. So now imagine you're the client. It's not a Claude desktop or a ChatGPT desktop or Cursor or C-Line or whatever. It's some other thing. You're building your own client, which is maybe just another backend service on your system in your website, right?
Yep.
And that's Spring AI powered. It's Spring Boot, and it's got some Spring AI starters. Okay, there you've got the Spring AI chat client, which is your fluid DSL thing that allows you to talk to the backend, model that you've auto configured, right? You can then tell that chat client when you make a call that, because it'll call the model for you, and you can tell that model, hey, for your consideration, I've got the following tools available to me. So you point it when you make that call to an MCP client, which has been in turn configured to point to the host and port on which you were running that MCP server. So that in practice, that's just one extra line from your regular Spring AI chat client use case.
Right.
And you might write the bean definition for the MCP sync client. That could be 3 lines of code. Right.
And to be clear, is it the fact that I've written sensible, useful English prose on my function API that means that the LLM will know this is worth calling now?
It has some sense of the shape of the method. It knows about the parameters and all that. But yeah, that human language text is how it reasons as to whether it should call this in this particular context.
That's actually really cool.
Very cool. And we have multi-line strings in Java, so there's no reason you couldn't put whole paragraphs in there,
The luxury.
Yeah. Or you could actually point it to a resource file, which is just a file.
Yeah.
Right. So, I mean, you have options,
That sounds like a lot of fun to play with.
It is. I mean, it is. I'm drunk with power now because when I'm 41 and I started, I don't want to even think about it, but when I started working, we all talked about SOA, right? And we all talked about SOA. We talked about service-oriented architecture. I'm going to build services with SOAP, and I'm going to have this WSDL schema, and I'm going to make directories using UDDI to discover this schema, and it just became this morass. So I'm doing document literal versus RPC SOAP or whatever. I mean, just on and on
you
and on.
You spent your life building up the protocols and never getting the benefit, right?
Yeah, you just spent more time doing the glue than actually leveraging the thing that was glued, and so people very quickly became sick of it. And then eventually, 5-10 years later, here comes microservices. And now microservices was driven mercifully not by tech. It was not driven by this need to do not repeat yourself, right? SOA was all about, hey, wouldn't it be nice if I could reuse a thing over the network, right? There was no political statement there. It was just, I don't want to have to write the same code twice. And that code happens to live on another computer.
Yeah.
That's it. It's a technical discussion. Here comes microservices, and microservices are it's like REST will do because it's not about, it didn't actually do, as we find out. People ended up building hypermedia and, open API and specs like that to plug in the considerable gaps in just plain REST. But it was all about organizations and all that. But I still remember the halcyon days where we all dreamt that, okay, we're going to have all these web services and we can just start pulling them in like importing modules in a JDK, right? I could just import this actual computer service, and I start using it, and I'd be able to add, and it would just be this tapestry of services that are available, and I could just start pulling them in, right?
Yeah.
And that was the whole, that was the Kool-Aid that they were selling with distributed COM in Windows and EJB in the Java use case, right? And user space, and none of it really panned out because the integration became so painful. Right, the whole thing was, it was meant to be like, oh well, we can trust the computer to be reliable and available, and of course that's never true.
Yeah.
Right. And so even if you got past the fundamental friction associated with distributed computing, you still have to deal with, how do I glue, And now, I don't need to do all that much. The model can reason for me. I can point it at a thing and say, here's a function, here's a description. If that looks like it can do what it needs to do for you, it'll figure out what parameters for my context and my query need to be passed into the parameter list. There's no mapping required for me here.
And so I have to ask, you said we've been sold this dream before. Do you actually see it panning out in reality?
Yeah, because it's already there, right? I mean,
you've been using it.
Yeah, no, well, not just me though. That's the thing. Like, there's almost every experience, including OpenAI, every experience I can think of has now added support for tools. Right, MCP is the most common standard, and I think the only one that wasn't using it was OpenAI, and they announced it like a month or two ago. Right. So yes, I think that's going to be, and I think it's going to change. Like 5 years ago, if you'd asked me what the MVP for any given service launched would have been, I'd say you got to have a web browser experience, one that works in desktop and phone, mobile. You got to have an Android app and an iPhone app, right?
Yeah.
In a pinch, I would have said just the iPhone app. Now I think realistically, you should have a chat experience. Like and I'm not saying we're all done yet. There's still, unfortunately, some gaps. So the trick will be to preserve the simplicity of the current state of things with MCP, whilst plugging those holes, whilst also evading or avoiding the complexity pitfalls that we saw with WS Star from 25 years ago.
Yeah,
right?
When was that?
Yeah. So, and for example, security. What's that look like? So a simple answer is just use an OAuth. Well, the people behind the spec released a draft a couple of months ago that sent the internet into a tizzy because the spec proposed that everything use OAuth. That is to say, every MCP service be an OAuth server. So remember, when I say OAuth servers, I mean a thing that produces tokens that, if you have that token, identifies you as acting on behalf of Josh or Jane or whoever, right?
Yeah.
So that token is lightweight. You carry the token. It's a short-term credential, right? You can throw that credential away, or you can even leak it, and it can be revoked centrally.
Yeah.
And with the token, you never usually have the ability to lock somebody out of their own account, right?
Yeah.
So you want something to identify the user by letting them log in, and something to provide those tokens, and then something that when it sees a token can validate that token is actually a valid one. It belongs to Josh, and he or she or whoever said that it's valid and it was good as of 5 minutes ago, and blah, blah, blah. Okay.
On the surface of it, it seems quite sensible to build that into MCP.
Well, I think OAuth is a good fit, but to understand why what I'm talking about doesn't fit, OAuth is the identity provider. It's the thing that it does all the hard work. It validates that a user is who they say they are. It issues tokens, and it validates tokens that it sees. What are some examples of an OAuth identity provider in the wild? Okta, Keycloak, right?
Yeah. Okay.
Auth0, Facebook, Google,
yeah.
GitHub. All of you have to sign in with Google. You click on the button, it redirects you to google.com.
Yeah.
They are your identity provider.
Yes. So what you're saying is we don't want to have to set up brand new identities
for every single
service.
MCP service. No, that's insane. So instead, finally, after and they're responsive to feedback, and that's why I love things like this. They're scrappy. They're willing to change. They are changing very quickly, and it's getting better by the day, and you can see it. Right. Well, another thing was, and by the way, we have the Spring Auth server in the Spring team. The Spring Auth server is, you go to start.spring.io, choose Auth server, hit enter, and now you have an embedded authorization server. Arguably, the only group, I don't know any other community that has a full OAuth IDP that you can add to your build by just adding a library, right? So arguably, the only group that could have actually done that horrible spec was us, and we still pushed back very, very mightily against it, right? We didn't want that at all, right? So that's been fixed. That now they're saying, okay, no, each MCP service should be a resource server, right? That's a more natural fit, like a REST API that's protected by these tokens.
Yeah.
Okay.
Makes sense.
With a filter, and then what was the other thing? You mentioned something a second ago. Oh, I mentioned they added another feature in the original draft of the spec. It's a stateful, long-lived server-side streaming connection, service and event stream connection.
Okay.
Well, what happens if the person goes through a tunnel and the Wi-Fi cuts out or the signal cuts out? Do you have to do you start from the beginning? Well, yeah, right. There's no resumption, so they just added to the spec a token for session resumption, so you can pick up from where you left off.
Yeah, I'm slightly surprised that wasn't in there from the beginning, but
again, simplicity is prevalent here, right?
Yeah.
And which I appreciate. I'd rather us deal in terms of flawed but simple ideas that we can then refine.
Yeah.
And if it's flawed and simple, at least we can figure it out quickly. We can see it.
Yeah.
As opposed to just trying to build for everything and every use case, right? And in fact, the original draft of the spec, the first implementation of it wasn't even HTTP. It was just standard in, standard out on the same host.
Oh, really?
Yeah. So Cloud Desktop, until recently, I don't think they even supported HTTP, right? The idea was that you had to have other things running on a process on your same machine. The idea was that you'd wield these things from Cloud Desktop.
Right, yeah.
You'd have a JSON config file that ran, that you, in the JSON config file, you would point it to a binary that, if Cloud Desktop ran the binary, would speak the standard in, standard out protocol to Cloud Desktop. So that's why I mentioned the music synthesizer and the 3D Blender 3D. Those are running on the same machine, one assumes.
Yeah.
Not over HTTP.
I can see the assumption, but actually just going over the network gives you far more options.
Well, for enterprise, certainly, yeah, like for services, right? So now both are supported. You can use Spring AI to build both in either, and it's very natural,
Okay.
Yeah, I'm a fan.
Bright future. I know you have to go and grab a plane.
Do
So I'm going to ask you one more question, just
One more.
speculatively for the future. What else that we haven't talked about is coming in the pipeline, perhaps in the distant future, that you're excited about?
Oh boy. I mean, how distant? Can I talk about November?
You can go all the way into November.
November, we're going to be talking about, we'll have Spring Framework 7 and Spring Boot 4, which are new baselines, new upgrades, lots of nice new features.
Tell me quickly, what's new to say in the world of Spring?
Well, again, Spring AI 1.0 GA coming out in 20 May 2025. So if you're listening to this in the far-flung future with our flying cars, tell me how we get there. Yeah, by that point, hopefully Spring Framework 7 and Spring Boot 4 will long be in the rearview mirror. But it's coming up. It's not here yet. It'll be here later this year. We're going to have there's lots of like nice projects that are going to become GA and become that'll be built against that, and that I think will be sort of better for their existence. So Spring AI will of course support these new baselines. Spring gRPC is a new project. We've had so many great community run gRPC projects that the Spring team proper never felt the need to build one. But those have kind of stagnated, and they never, none of them, because of the way the Protalk gRPC compiler works, you end up doing code generation, and it's always felt like it's just not very idiomatic Spring. People write Java code, they write plain old Java objects, POJOs, right? These are just objects with methods.
Yeah.
And the assumption is that you can map those methods to invocations of a HTTP endpoint or RSocket or GraphQL or whatever. So for gRPC, it's sort of, very much against the grain there. You're forced to deal with the generated code.
Yeah.
And so that's gotten a lot easier. We're working on a component model that's sort of early days yet, that you can already use it for everything that the existing projects in the community did, and it's been updated, and it's got a good security support and observability, and it works with GraalVM native images and all that. So it's already a better fit than a lot of the existing community options. But
what you're saying is you think Java's going to take the crown from certain other fields that we're excited about now and keep the interop integration crown that it's had for a while?
Yeah, I think it's already taken a lot of that. I don't think it's a matter, I don't think there's all that much to go, right? I think what people have been complaining about was the ceremony, right? And your lament is not unheard of, right? We've heard this before.
No, I'm not.
So a lot of that has been reduced, and people who are patient will realize that the occasional wart, the occasional bump in the road are far outstripped by the immeasurable benefits of the platform, the community, the technologies, the richness of the ecosystem, and the performance, security, and observability benefits you get there, right?
Okay.
It's just it's a really interesting time to be a Java and Spring developer, I think.
I'm down in the Rust mines at the moment. When I come out, I promise I will update myself.
Rust is one of the few places where I don't know that I think they're going to swim in parallel paths. And, again, I don't think you would ever use Spring to build a kernel extension, but you could definitely use Rust, right?
Yeah.
I like Rust. Good stuff.
Yeah. Cool. Josh,
thanks for having me.
Very much.
Appreciate you.
Fascinating. Cheers.
Bye, everybody.
Thank you, Josh. And I'm now officially looking for an excuse to write something new in Java. That's not a sentence I was ever expecting myself to utter. But that's good. I take this as a good sign. The whole point of this podcast is to learn new and unexpected things. So, Josh, you did it. Thank you. As ever, you'll find links in the show notes if you want to follow up on any of those threads, virtual or otherwise. And this seems like the right moment for me to take a brief pause and say thank you to Modern and Open Rewrite for being our hosts for that conversation and some of the other conversations coming in the next few months, and for their long-time support on Patreon. I really appreciate it. It helps keep the podcast going. So thank you. All the best companies support developer voices on Patreon, or will soon, I'm sure. If you want to support us, Patreon's a great way to do it. Telling your boss to support us on Patreon is another great way to do it. Link in the show notes. But just clicking like if you've liked this episode, or share if you want to tell a friend, that's enough. For now, I've been your host, Chris Jenkins. This has been Developer Voices with Josh Long. Thanks for listening.